All right, now we are going to talk about ICMP briefly. In a few minutes, we are going to talk about ICMP briefly.
Okay, show
and
me the
I
books.
already told
Show
you.
me the books. Show me your books, please.
I already told you that ICMP is there to help what? IP. It is used to transmit error and control information between network devices. It plays an extremely important role. Okay? In order to improve the efficiency of IP, data packet forwarding, and the success rate of packet exchange, we use ICMP at the network what? Layer. It allows hosts and devices to report errors during packet transmission. So when you receive something like request timed out, something like destination network unreachable, something like destination host unreachable, something like port unreachable, something like reply from this, all that is ICMP at work. Are we together?
Yeah.
An ICMP message is encapsulated in what? IP. ICMP does not have layer 4 or layer 5 or layer what? No. It is directly encapsulated in what? In IP. And how we know that a message in the IP header belongs to ICMP, what did we say? Is in the protocol field. In the protocol field of the IP header, there will be a 1. That is how we know this message is for ICMP. Are we together?
Yes.
And this is the message that ICMP has a few fields: the type, the code, the checksum, and the contents of the message. Okay? Now, the type field indicates the message type, and the code field contains parameters that map to that particular message type. I told you what all checksums mean. They are there only to check the validity of the what? Of the message. Is it valid? Has someone tampered with it? That's it. Now the message content varies. It depends on what is the type of the message and what is the code for that type. Are we together?
Yes.
Yes.
Okay. So we have several types. On this slide, we have listed 1, 2, 3, 4, 5, but you notice that all this is one type. Do you see that? So 1, 2, 3, 4 types we have listed in this slide. Only 4 types. Type 0, type 3, type 5, and type 8. So what is type 0? Type 0 is echo reply. Okay? What is type 8? Type 8 is echo request. So when you do ping 1.1.1.1, your host, the sender, will send an echo request to the receiver. You will send a type 8 message with code 0, an echo request. The receiver, on receiving, will send an echo reply, a type 0 with the code what? 0. Are we together?
Yes.
Now, type 3 is a type for unreachable. Are we together?
Yes.
Type 3 is a type for unreachable. So, different codes tell us what exactly is not reachable. Is it the network? Is it the host? Is it the protocol? Is it the port? Now, normally in your Windows, you'll find destination network unreachable, destination host unreachable, okay? Protocol unreachable. You'll see something like that, but at the lower level, they are the types and the codes of ICMP. Now, ICMP has about 3 functions that I want to explain. Applications, I should call them applications. Number 1, there is what we call the ICMP redirect. Are we together?
Yes.
And number 2, we have what we call ping. Number 2, we have what we call what? Number 3, we have what we call trace what?
Trace route.
Trace route or trace route. Let us look at the redirect. When do we use the redirect? Look at this topology very well before I explain it. Have you seen it?
Yes.
Now, this host has been configured with that IP address and this default gateway. Please notice that this host is connected to routers, that one and that one. Carefully try to understand this. That means when the host wants to communicate to any network that is not his local area network, he will send the packets to the what? To that gateway. Are we together?
Yes.
Now, someone on this host tries to access this server 20.0.0.1, which is not on our local area network. What is going to happen? The host will send the packet to the gateway. And then because the gateway has a routing table, it will check the routing table and know that to reach this destination, it needs to send the packet what? There. Are we together?
Yes.
Now the problem is if the gateway sends the packet there, the reply will come and come here and come here. Do we see that?
Yes.
Okay.
And when the host wants to communicate again, it will send here and the gateway sends here. The reply comes, it will come here and then the gateway receives it. Do you see there is too much traffic for no reason?
Yes.
So when the gateway notices that the host is in fact on the same network with this other way that leads to this network faster, instead of forwarding the packets by himself, the gateway will instead send an ICMP redirect. You tell him, wait. The guy you want to receive is better reached when you just send that sign. And so the host will re-encapsulate and send the packets there. Are we together?
Yes.
Yes, sir.
That is
Clear.
what an ICMP redirect message does. Now, ICMP also is used for error detection. That is using the ping application. Most of us have used this. I'm not going to talk about it a lot. Okay? You just do ping and not specify the destination you want to see whether you can reach. What goes is an echo request. What you get is an echo reply. In the messages here, you never see the request. You see only the reply with special details. And then it gives some statistics. Oh, we sent 5 packets and received 5 replies. 0.00% was lost. The minimum transmission time or round time for going and coming back was 30 milliseconds. The average was 40 and the maximum was what? Was 70. How does it get the 40? It adds 30. You guys know how to get average, right?
Yep.
So ICMP error report is also that one that you get. This is still either from trace route or ping. You get this. I told you earlier, trace route is actually an application of ping. You remember?
Yes.
It simply does ping, gets the reply, then does ping again, gets the reply, then does ping again like that by manipulating the TTL value in the IP header. So the error report, like destination unreachable, host unreachable, network unreachable, that one is also an application of ICMP. So traceroute is one application, ping is one application, ICMP redirect is another application of ICMP. Okay, these configurations, we have done them quite a bit, and I'm going to set up a simple network in ENSP and do this so that those of you who have not done it before can know where to start from on the exercise I'm going to give you. Are we together?
Oh. Yes.
All right, so I'm going to get an ENSP screen shared. And then what am I going to do? I'm going to click on this router and drop it here, and I'm going to get another router and drop it here. And then what am I going to do? I'm going to, excuse me, I'm going to get a copper connection and connect gigabit Ethernet 001 to gigabit Ethernet 001. After that, I'm going to, well, I'm going to configure a few things here, but let me first do labeling, okay? I'm going to configure a network 192.168.1.0/24. On this end, I'm going to put, a dot 1, okay? And then on the other end, I'm going to put a dot. Let me put the dot 1 on this end, because this one is router 1, okay? And on this end, I'm going to put a dot 2. You guys know what this means. This means the IP address here will be 192.168.1.2. And the IP address here will be 192.168.1.1. Are we together?
Yes.
Now, I'm also going to configure a loopback address here. I'm going to configure loopback address 0, which is going to be 1.1.1.1/32. It's going to have a 32-bit subnet mask. I'm also going to configure loopback 0 this side. And it's going to be 2.2.2.2/32. Are we together?
Yes. Yes, sir. Yes.
Okay. So this is what I'm going to set up, basically. This is dot 0, please note. Knowing the interfaces is important, because when we are configuring, we are going to configure those interfaces. So I start up the devices. That labeling helps me when I'm configuring. I don't have to be opening the device. All right, so I'm going to extend this to that side. And I'm going to click this button here to open both devices in one box. Like that. So I have router 1 there and router 2 there. Router 1 is on the right, this one. Router 2 is on the left, this one. They are unfortunately both called Huawei at the beginning. So the first thing I'm going to do is get to the system view. And then I'll change the system name to AR1 for router 1. And then for router 2 also, I'll get to the system view. And first thing I'll do is change the system name to AR2. Okay? Now on AR1, I want to go to this interface gigabit Ethernet 000. How do I do that? From system view, go to interface gigabit Ethernet. You can abbreviate that with G000. I'm inside the interface, you can see. And then I'll give it an IP address 192.168.1.1. Subnet mask is /24. We can always do that by just putting space and a 24, or we can do that by writing the whole subnet mask. But who wants to write a very long one when there is a way to write a short one? So 24. and then I'll quit to come back to system view, and then I'll go to interface, loop back 0. Now, please note, when I type this command interface loop back 0, it creates an interface, display IP interface brief, excuse me. You see, it creates an interface called loop back 0. A special thing with this interface that it is up and up even before you give it an IP address. So now I'm going to give it an IP address, 1.1.1.1/32. Don't put the stroke when you're configuring. Okay? You can always confirm your configurations by typing display this, and it will show you what you've just configured there. I can type quit to go back. I'll go to interface, gigabit Ethernet 000, and also type display this to confirm what I configured there. That's what I configured. Are we together?
That's a big one.
Yes.
The big one is nice.
Are we together?
Yes, yes, sir.
Now I'll go to the second device, and I'll go to interface, gigabit Ethernet 001. Okay, and I'll say IP address 192.168.1.2/24. I'll quit out of that interface. Before quitting, let me just confirm, display this, and double check to see, oh cool, that's it. Then I'll quit and go to interface, loop back 0. And I'll give it an IP address 2.2.2.2/24. Again, I'll say display this just to confirm. I like double checking my work because it takes longer to troubleshoot. Even after displaying this to confirm, I like saying display IP interface brief, and it shows me, excuse me, display IP interface brief, and it shows me that you have put an IP address on 001, and that's the IP address /24. Let me see. Yeah, that's it. And on loopback 0222/32. Yeah, cool, that's it. And then on router 1, I'll first quit out of the interface and say display IP interface brief. And then I'll see that on 000, let me see, yeah, 000, 191.68.1.1/24, 192.168.1.1/24. Cool, that's it. And it's already up. Then I see, oh, cool. Now, this interface is on the same network with this one. They should be able to ping. So I'm going to be on router 1, and I'm going to ping 192.168.1.2. That is router 2. Ah, cool. There is connectivity. There is communication on my what? Network. Are we together?
Yes, yes.
Okay. So basically, that is what I'll need you to do. Later on, we shall see what to use the loopback interfaces for. That is an exercise for you, by the way. That one I've just done is an exercise for you.
Okay. Okay.
Yes.
I have an issue with my ESPN, and I had sent a
SBN?
screen. Yeah, no, I'm saying
Hey,
I have an issue
with?
when like I'm trying to run those commands. Yesterday I sent my ENSP. I sent a screenshot on the Telegram, but I wasn't helped.
Oh.
Yep.
When you try to run the commands, what happens?
Yeah, it just gives me an error.